Might Proxima b ever become another Earth-like planet?
Where the Hubble Space Telescope and
These are hypotheses everyone keeps making. The journey for an alternative, habitable planet and the search for extraterrestrial life on various planets fascinate people. There have been various theories, and the fact that signals have been detected coming from Proxima b makes people believe there is more to it. Regardless of these intriguing signs, we still cannot determine whether they are messages from the planet or simply echoes of our own signals. Often, these signs end up as dead ends in the mission for extraterrestrial life. Experts want to decide whether extraterrestrial life exists by determining if these signals truly come from Proxima b. Recently, the James Webb Space Telescope detected artificial lights on Proxima b. If you're excited about learning about various planets and our progress in finding extraterrestrial life, subscribe to our channel. We create content about space and discuss advancements in science. If you enjoy this content, leave a comment below and share this video with your friends. Now let's dive back into our video. Proxima Centauri, located about 4.2 light-years from our nearby solar system, is a red dwarf star classified as a G-type star. Hence, the star is known as Proxima Centauri. It is the closest star to our Sun and planetary system. It was named Alpha Centauri by Johann Bayer in 1603, based on the star's appearance around noon when a few celestial bodies like the Moon and the Sun were aligned. Proxima Centauri, also known as Alpha Centauri or Alpha Centauri A, is a single star system with 4 main stars aligned in a line. Proxima Centauri is at the center of the system. Apart from these stars, there are 2 faint dwarf stars, Alpha Centauri B and Alpha Centauri C, which make up most of the mass but are too faint to be seen with the naked eye. The system is located 23 degrees away from the famous Plough asterism in the constellation Centaurus. Despite Proxima b being a rocky planet, there is still hope that it could harbor extraterrestrial life. The search for life elsewhere has led scientists to Proxima b. They believe its similarities to Earth's size and its distance from its small star make it a viable candidate for supporting life. While this is speculative, there is hope that these theories could hold some truth. There is still much to learn about Proxima b and its orbit, so stay tuned for updates. You can also explore some of our other content related to extraterrestrial life. Do you believe there's life out there? Leave a comment below. What impresses many people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet orbiting an M-type star. Its mass is about 1.27 times that of Earth. Proxima b takes 11.5 days to complete its orbit around its star. It was discovered in 2016, and various researchers are studying it. Despite its Earth-like characteristics, Proxima b has specific features that make it unsuitable for life. For one, the planet is too close to its star, meaning it receives extreme ultraviolet radiation. It is estimated to receive much more radiation than Earth gets from the Sun. This radiation is so intense that it strips away even the lightest hydrogen atoms over time, as well as oxygen and nitrogen. While many argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, distance alone doesn't determine habitability. Factors like the presence of water and an atmosphere conducive to life are crucial. The atmosphere on Earth makes it habitable, while Mars lacks the necessary conditions. The right atmosphere allows for climate regulation, a water-friendly surface, and protection from hazardous space conditions. If you're with us this far and haven't subscribed yet, take a moment to hit the subscribe button. It helps us keep creating content you'll love. Now, let's explore why people believe the James Webb Space Telescope will help determine if there is life on Proxima b. The James Webb Space Telescope was launched in 2018 after delays since 2011. Multiple modifications were made to ensure it provided accurate images. Experts explain that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb Space Telescope was specifically designed to observe infrared light. It can capture images of this light on a planet's surface and analyze patterns to confirm if the planet has water or an atmosphere. Space telescopes are preferred over ground-based ones because they avoid interference from Earth's atmosphere, providing a clearer view of deep space. Additionally, weather conditions on Earth don't affect them, ensuring astronomers get accurate readings. The main downside of space telescopes is the high cost of repairs if something goes wrong. For instance, a minor flaw in a space telescope may require an entire mission to fix it. These costs make observing planets like Proxima b challenging, as we have no repair options for the James Webb Telescope. The telescope has been launched over 1.5 million kilometers away, farther than any human has ever traveled, making rescue missions impossible. However, the James Webb Space Telescope has a larger mirror, enabling us to see back to the beginning of the universe, nearly 13.7 billion years ago. The further away an object is, the further back in time we can see, as light takes time to travel from the object to us. The James Webb Telescope's ability to observe longer wavelengths and infrared light allows us to see distant galaxies with greater resolution than ever before. As a result, studying planets like Proxima b has become easier, as it shifts light from the visible range to the infrared. Researchers like Tabor and Bend have developed a scale to measure artificial light on planets, considering the fraction of sunlight illuminating the planet's day side. The night side is totally dull at 100%. It implies the planet's night side is pretty much as bright as the day side. There has been theoretical work on Proxima b using this sort of light, and most experts believe it's similar to Earth's early days. Studies show that if the night side of Proxima b is illuminated to 5% of the average daytime brightness, the James Webb Space Telescope could detect the artificial light by 85%. If the illumination reaches 9%, the telescope could detect it up to 95%. Although 5% brightness may seem small, we're talking about light from a star as distant as Proxima Centauri. Compared to our Sun, it's multiple times dimmer, yet we still receive significant light from our star. This means that even at 0.1% brightness, we are still reflected in the celestial light. In other words, if Proxima b has any civilization emitting light like Earth, the James Webb Space Telescope wouldn't be able to detect it unless the stars were significantly brighter. This scenario is unlikely given that Proxima b orbits so close to its host star, possibly being tidally locked. This means one side of the planet always faces the star while the other remains in perpetual darkness. A civilization living on a tidally locked planet would likely need to focus on lighting systems and use extremely bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. These are theories proposed by Tabor and Bend, but there is still no evidence to prove they are valid. Earth's brightness can be seen from space and is known as airglow. Many people wonder why the world is surrounded by brilliant shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. Airglow occurs when particles in the upper atmosphere emit light to release excess energy. On Earth, airglow happens when particles and atoms are ionized by sunlight and capture free electrons. The glow resembles an aurora, except auroras are driven by high-energy particles from the solar wind, while airglow is driven daily by solar radiation. Since the James Webb Space Telescope's launch, scientists have been studying whether it's sufficient to observe distant planets in faraway universes. Although it is the furthest space telescope launched, it still provides limited data needed to discover planets with life. There have been discussions about developing larger and better telescopes. These projects are often expensive and involve a lot of trial and error. The James Webb Space Telescope's launch was delayed by 7 years due to these challenges. Thus, it is crucial for most researchers to develop better technologies that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising. Soon we could know whether there is life on Proxima b and other planets. While work is ongoing on additional telescopes, it is hoped that the completion and launch of the Habitable Exoplanet Observatory, HABEX, will revolutionize space exploration. The estimated completion time for HABEX is 2035, with a launch shortly after. HABEX will be sensitive to all planets in the universe, and its primary goal is to search for Earth-like planets. Its cutting-edge technology will allow it to measure the spectra of most planets and determine their habitability. HABEX is also believed to have a wide range of astrophysical capabilities, enabling it to study the earliest possible times in human history, gather data, and understand the life cycles and deaths of massive stars, as well as the factors that support life as we know it. Though HABEX is still under development, the technology used to create it will allow it to study Earth-like planets with such precision that images from these planets will be incredibly clear. HabEx will be sensitive to ultraviolet, optical, and infrared light. The concept behind HabEx is highly compelling and could transform space exploration as we know it. If it succeeds, space exploration will undoubtedly change, and people can look forward to more information about extraterrestrial life on other planets. It will also provide a clearer picture of Earth, allowing us to look back at the planet's history and the changes that have occurred in our environment. LUVOIR, Large Ultraviolet Optical Infrared Surveyor, is a smaller version of a telescope but builds on our experience with the James Webb Space Telescope. It has ultraviolet capabilities and is considered the next observatory telescope to be used by most astronomers. Space experts aim to launch LUVOIR simultaneously with HabEx. The large UV/optical sensor will greatly enhance space exploration. Studies conducted with LUVOIR show that it will be able to understand what makes Earth stand out from the rest. Some observations have been made of 28 Earth-like planets, and the results have been promising. With such telescopes, understanding planets like Proxima b can become clearer. Although the James Webb Space Telescope has made significant progress in finding new information about Proxima b, much work remains to improve the visibility of other planets and the ability to detect atmospheres more accurately. This will help answer whether extraterrestrial life exists. It will also provide further insights into the planet's history and analyze the changes that have occurred over the years. Have you ever wondered what would happen if we discovered extraterrestrial life? Don't worry, we have videos on our channel that discuss this and much more. Subscribe to our channel and hit the notification button to be alerted whenever we post new content. Is there life beyond planet Earth? The debate about life on other planets has been ongoing for some time now. Many people believe that we are not alone in the universe. There have been theories and claims made for decades, but whether we will ever know if life exists on other planets depends on the type of research we conduct. Scientists are working to ensure that we have more space telescopes orbiting Earth and other planets. However, these telescopes must be more advanced and look beyond infrared lighting to provide better answers about extraterrestrial life. For now, we watch with bated breath as we hope to determine whether our neighboring planet, Proxima b, harbors any life. If you enjoy content like this and want to learn more about the James Webb Space Telescope and Proxima b, please subscribe to our channel. We post videos regularly, reviewing telescopes and examining evidence of Earth-like features on other planets as we search for life beyond our world. Recent advances in astrobiology have reignited interest in the potential for life on exoplanets. Particularly Proxima b researchers are exploring the planet's surface features and composition to better understand its habitability. For example, studies focus on identifying the presence of liquid water, a critical element for life as we know it. Additionally, the planet's atmospheric conditions are a subject of interest. Scientists are investigating how its proximity to its star affects temperature fluctuations and atmospheric composition. These factors could determine the viability of habitats, should they exist. The idea of biosignatures, signs of life such as specific gases in the atmosphere, has become increasingly important. Researchers are developing models to predict what biosignature profiles might appear on Proxima b, enhancing the search for extraterrestrial life. Interdisciplinary collaborations among astronomers, geologists, and biologists are essential for refining our understanding of potential life on exoplanets. These teams aim to devise comprehensive approaches for future observations, using both current technology and innovative ideas for upcoming missions. As we refine our search methods, excitement around Proxima b continues to grow, highlighting humanity's quest to explore the universe and uncover the mysteries of life beyond Earth.